All right, so I meant to say at the end of the last video that you should now be able to do 2.6 day one homework. This is posted in the Haiku site, but the homework will be the front and back, and it just mimics the types of problems that we covered in class. And I'll post solutions at the very end of the day that it's actually due. So this day one practice will be due on Wednesday. So I'll post solutions on Wednesday for that. And then day two, we then will take notes. So again, day two is on Wednesday. Basically, what this is a little more complicated problems related to literal equations. So let's go ahead and go over these day two notes. Again, go ahead and just pause the video because I'm going to go directly into how to solve these two warm-up problems. But you should especially be able to do problem A because this is just a two-step equation. There's only one variable and we're being asked to solve for what exactly that variable is. And then onto the right, it's something a little similar, but now we have two variables. This is now a literal equation. We're solving for y, and so we're trying to get y by itself, and then everything, including that x variable, must be on the right-hand side. So go ahead and pause and try this on your own, but I'm going to, again, go into the solution right now. So looking at problem A, solve for y. Again, this is just a two-step equation. The first thing I need to do is, so I got my two sides of my equation. I'm focused on the left-hand side because that's where my y variable is, and I need to get that y variable by itself. The first thing I need to do is get rid of the constant on this side. So this 3, I need to subtract away because it's positive. I'm just doing inverse operations. If I subtract 3 on the left, I have to subtract 3 on the right. So on the left-hand side, 3 minus 3 just goes away. It's 0. And I'm left with a positive 2y on the left-hand side. And that's all equal to, on the right-hand side, I have 15, but then I also had to take away 3 to balance my equation. Well, 15 minus 3 is 12. I'm not done because y is not by itself yet. I have 2y equal to 12, so I have to undo this 2 in front of my y. Well, this 2, because it's directly in front of my y with no plus minus in between, it's assumed to be multiplication. So 2 times y equals 12. Well, to undo that multiplication, I have to do the inverse of multiplication. So I have to divide by what exactly that number is, that coefficient in front of y, which is 2. The reason why that's super helpful is because 2 on top of my fraction, 2 on the bottom, aka 2 divided by 2, it's just 1. Essentially, they cancel each other out, and I'm left with just 1y on that side. And that's all equal to, well, on the right-hand side, I had a 12, and I had to divide both sides by 2, so this side is divided by 2 as well. And 12 divided by 2 simplifies to be an exact whole number, which is 6. And I've reached my solution. Y is equal to 6. Again, we could check to make sure that's right. Like if I plug this back into my equation, so 3 plus 2 times what I said y is, which is 6, and I get 15, it better equal 15. So this does, the solution does check out. Now on the right-hand side, this is a little more complicated because we just learned literal equations. So in this problem, we're being asked to solve for y, but again, there's another variable, this 4x. So in this problem, the first thing I need to do is, first of all, I have my two sides of my equation. And I'm kind of focused again on the left-hand side because that's where this y is. And I need to get rid of everything around that y. I need to get rid of this term, the 4x, and then I'm going to eventually need to get rid of this coefficient of negative 12 in front of my y. Now, this one's a little more complicated than we looked at yesterday because it's a multi-step problem. Technically, it's just 2 steps. In problems like this, the first thing you want to always do is to get rid of any terms that are being added or subtracted to like your y grouping. So we have this term here, this negative 12y. We're gonna save that to like the end. All of your y's, we're just gonna keep on carrying down all the way into the last step. What we wanna get rid of first is any term next to it. Well, this is just a separate term, this 4x. So in order to get rid of those 4x's on that side, we have to do the opposite of that. Well, this 4x is technically being added on this side because there's an invisible positive symbol in front. So in order to undo, or in order to get rid of a positive 4x, we have to do the opposite, which is subtract. We're going to subtract off 4x on this side just to get rid of it. Well, if I subtract off 4x on the left-hand side, I have to do the exact same thing on the right-hand side. And notice, when I write that, I kind of wrote it kind of far to the right off of this 24. Because these are not like terms, I don't like line them up together. We're not going to be able to combine these. They're not like terms. So the reason why this is beneficial and the reason why it helps us out is because we just got rid of this 4x on this side. A positive 4x, I have 4 x's, and then I take away 4 x's. I have no x's left on this side. I've essentially canceled those x's out. What I do have left over on this side is a negative 12y. So I'm going to bring that down. A minus 12y. Got my equal sign. And then on this side, again, I cannot combine these. They're not like terms. So I just have, I'm not going to be too picky about the order in which you write this, but technically your variable should go first and then your constants. So on this side, I have a negative 4x. And then next I have my constants, which are just a positive 24. Again, the symbol in front of this 24, there is nothing in front of it, so it's assumed to be positive. I'm not done because I haven't solved for y. I now have this coefficient in front of y that I need to get rid of, this negative 12. Well, again, this negative 12, invisible symbol in between, it's multiplying my y. So how do I undo multiplication? I divide. That's the inverse operation. So I have to divide by this coefficient of negative 12. And if I divide by negative 12 on the left-hand side, I have to divide every single term on the right-hand side by this negative 12. So I'm going to divide this first term by negative 12. I'm going to divide this second term by a negative 12. So I divided every single term, both terms on the right-hand side by that negative 12. So on the left-hand side, a number divided by itself. That's essentially what I have. A negative 12 divided by a negative 12 is just 1. So I'm left with just y on that side. Perfect. That's what I was trying to do. On the right-hand side, though, for this first term, I have a negative 4 on top, and I have a negative 12 on the bottom. When you stick that in your calculator, you're going to get an ugly decimal. So we need to I'm going to do a little side work here. But I have a negative divided by a negative. That's just a positive. And then I have 4 on top, 12 on the bottom. Well, both of those numbers are divisible by 4. So if I divide out a 4 on top and a 4 on the bottom, I can simplify this fraction. 4 divided by 4 is just 1. 12 divided by 4 is 3. And don't forget that I have my x as well. I can check to make sure that fraction is the same, like 1 over 3. I better get the same decimal, and I do. So negative 4 divided by negative 12 is the same thing as 1/3. See how they have the same decimal value. Now I have a positive 24 divided by a negative 12. So a positive 24 divided by a negative 12. Oh, that's a whole number. It's just a negative 2. So a negative, or subtract away, 2. And that gives me my final answer then. Y is equal to 1/3 x minus 2. So down below, that was just the warm-up. Down below is where we would actually go into like all the notes. So this first set of notes is just a reminder of how literal equations work. The first thing there says identify that variable that you are trying to isolate. That's what goes there. There's basically always a variable like, oh, solve for w, solve for k. Up above in our warm-up problem, we were solving for y. So the first step is always to identify the variable that you're trying to get alone. The word I'm using is isolate, which just means to get alone. Which variable are you trying to solve for? That's always the first step. Got to look for that. How do you do that? Well, you use, same as before with one-step, two-step, and multi-step equations, we're using inverse operations. in order to get that variable by itself. So we're using inverse operations to move terms away from the variable that you're trying to isolate. I'm sorry I didn't include much room for this, but I gave just a little bit of advice down below and in the notes. Basically, when we're using inverse operations, what you're essentially doing is you're doing PEMDAS backwards. A lot of times you're using addition and subtraction first, and then you're using multiplication and division last. And then there's not going to be too much with as far as exponents or parentheses with literal equations, so we don't have to worry too much about that. But the first step is usually addition and subtraction, and then the last step is to multiply or divide. Just a little bit of advice with fractions. In order to get rid of fractions in your problem, we will always be using reciprocals. And then just a little last hint is that the last step, and I just kind of talked about this, the last step will be to usually divide, sometimes multiply, by whatever is next to your variable. But again, it's usually division. So let's look at some sample problems down below, starting with number 1. So we're being asked to solve for W in this complicated formula. P equals 2L plus 2W. Again, we're trying to get this W by itself. So we're going to have to eventually get rid of this 2 and then this 2L, this other term off to the left. So we have our two sides of our equation. Again, we're going to essentially be using backwards PEMDAS. The first thing that we're going to do is either add or subtract. Essentially, we're adding and subtracting the other term that is with the variable we're trying to get alone. So we're trying to get this W, but this 2 belongs to the W. Essentially, this is like one term right here. And then we have our other term, 2L. So our goal is to get 2L, get rid of that other term first. And how do we do that? Well, this 2L, again, the symbol in front is positive. So I'm going to do the opposite of that, which is minus. I'm going to minus all of this, 2 L's on this side. Well, what I do on the right-hand side of my equation, I have to do on the left-hand side of my equation. So I'm going to subtract away 2L on this side as well. Notice I didn't line it up with the P because they're not the same variable. I cannot combine them. They're not like terms. So when I simplify, on the left-hand side, I have my variable P, and then I'm taking away 2L. So that's what I have on the left-hand side. I have my equal sign in the middle. And then on the right-hand side, I used to have 2L, but I took them both away. So essentially, they cancel each other out. 2L minus 2L is nothing. And what I'm left with is this positive 2W. So on this side, I have 2W. And I'm not done, though, because I have not gotten W by itself. I need to somehow now get rid of this 2 in front of W. Well, the question becomes well, what is this 2 doing to my W? Well, it's multiplying my W. So to undo that multiplication, I have to do the inverse operation, which is divide. Again, the last step is usually division, not always. So I'm going to divide both sides by that 2. I'm just going to go ahead and divide everything on this side by 2 instead of doing like each term individually, which is like up here I did each term individually. So technically there is another type of answer I could get here. So I'll try to do it both ways. Let me do it so you can kind of see what I'm talking about. So another way I could have done this problem, like I'd divide this side by 2, and I could divide each of these terms by 2. So either way is fine. I would have to accept either answer. So let's look at this first method first. 2 divided by 2 is just 1, so I'm left with just W on the right-hand side. On the left-hand side, though, there's nothing I can really do to simplify. I have my P minus 2L on top, and that's all divided by 2. So that's my final answer. I would also accept this. So if you divided each term on the left-hand side individually by 2, that's also legitimate. I still have 2 divided by 2 on the right-hand side, which cancels each other out, and I'm left with just W. On the left-hand side, P divided by 2, there's nothing I can cancel there. I have my minus sign in between. And then I can cancel something here. 2 on top, 2 in the bottom, kind of similarly. They cancel each other out, and I'm left with just